Hello everyone, in today's topic, we are going to discuss about integrating exponential functions by U-substitution. So let us have the first example, the integral of e to the x dx. It is equal to e to the x plus c. And then we have the second example, the integral of e to the 2x dx. It is equal to e to the 2x over 2 plus c. And then the third one, we have the integral of e to the negative 5x dx, which is equal to e to the negative 5x over negative 5 plus c. As you can see here, if we are going to integrate exponential function, when the exponent has a numerical coefficient, it is the divisor of that function as we integrate it. And then always remember to add plus c. So this time we are going to determine the integral of e to the negative 5x dx using U-substitution. So the first thing we need to do here is to let u equals negative 5x. Then getting the derivative of negative 5x, it is equal to negative 5 dx. So we have du equals negative 5 dx. And then solving for dx, we are going to divide both sides by negative 5. So dx equals du over negative 5. Then we are going to substitute all the values. So we will be getting the integral of e to the u du over negative 5. And then over negative 5 equals negative 1/5. So we will be getting negative 1/5 times the integral of e to the u du. And then the integral of e to the u is equal to e to the u plus c times negative 1/5. And then substituting your u, it will be equal to negative 1/5 e to the negative 5x plus c. And then simplifying further, we will be getting e to the negative 5x over negative 5 plus c. Now let us have another one. We are going to determine the integral of x to the third e to the x to the fourth dx. The first thing we need to do here is to let u be equal to x to the fourth. And then to get the derivative of x to the fourth, it is equal to 4x to the third dx. And then getting dx, we are going to divide both sides by 4x to the third. So dx equals du over 4x to the third. And then we are going to substitute all the values. We will be getting the integral of x to the third e to the u du over 4x to the third. And then simplifying further, we can cancel x to the third and x to the third, it will become 1. Then we have 1/4 times the integral of e to the u du. So integrating e to the u, it is equal to e to the u plus c. And then don't forget to write 1/4. So we have 1/4 e to the u plus c. And then substituting the value of your u, the final answer would be 1/4 a raised to x to the fourth plus c. Now let us have another one. Let us determine the integral of e to the x, square root of 1 minus e to the x dx. So the first thing you need to do here is to let u be equal to 1 minus e to the x dx. And then we are going to get the derivative of u, which is equal to negative e to the x dx. Then we are going to divide both sides by negative e to the x. So we will be getting dx equals du over negative e to the x. Then we are going to substitute all the values. So the integral of e to the x, square root of u, du over negative e to the x. And then we can cancel e to the x and e to the x. So as you can see here, we have negative 1. So we have negative times the integral of square root of u du. And then we are going to rewrite square root of u, which is equal to u to the 1/2. And then integrating u to the 1/2, it is equal to u to the 3 over 2 times 2 over 3. As you can see here, we already get the reciprocal of 3 over 2, and then we proceed to multiplication. Since we have a negative sign before the integral symbol, we have negative u to the 3 over 2 times 2 over 3 plus c. And then we are going to substitute the value for u. So we have negative 2 over 3 times 1 minus e to the x raised to 3 over 2 plus c. So let us have another one. Let us determine the antiderivative or the integral of e to the x plus e to the negative x over e to the x minus e to the negative x dx. In here, let u be equal to e to the x minus e to the negative x dx. And then getting the derivative of this one, we have e to the x minus e to the negative x times negative 1. Negative e times negative 1, it is positive e. So we have e to the x plus e to the negative x dx. From here, we are going to have dx equals du over e to the x plus e to the negative x. Then we are going to substitute all the values. So we will be getting the integral of e to the x plus e to the negative 1 over u times du over e to the x plus e to the negative x. So as you can see here, we can cancel e to the x plus e to the negative x. It will become 1. And then we will be getting the integral of 1 over u du. So from here, it is equal to ln the absolute value of u plus c. And then substituting the value for u, the final answer would be ln the absolute value of e to the x minus e to the negative x plus c. Now let us have the second to the last example. Let us determine the antiderivative of e to the 1 over x squared over x to the third dx. The first step that we are going to do is to let u be equal to 1 over x squared, or we can rewrite this one as x to the negative 2. From here, we can have the derivative of x to the negative 2, which is equal to negative 2x raised to negative 3 dx. From here, we shall have du equals negative 2 over x to the third dx. We are going to multiply both sides by x to the third so that we can simplify. So the x to the third came from x to the negative 3. So we can rewrite it below. So the exponent will become positive. So we can cancel, and then we will be getting x to the third du equals negative 2 dx. Simplifying further, we will be getting dx equals x to the third du over negative 2. So from here, we can substitute all the values already. So we have the antiderivative of e to the u over x to the third times x to the third du over negative 2. We can cancel x to the third, and then we will be getting negative 1/2 times the antiderivative of e raised to u du. And then we are going to integrate e to the u, which is equal to e to the u plus c. And then please do remember to write negative 1/2. And then from here, we are going to substitute the value of your u, which is equal to 1 over x squared. So we will be getting negative 1/2 e raised to 1 over x squared plus c. We use 1 over x squared because in mathematics, we always wanted to have a positive exponent. So let us have the last example. we are going to determine the antiderivative of e to the 3x plus 4 e to the x plus 5 over e to the x dx. In this example, we can use also the integration by parts. So the first thing we need to do here is to separate all the terms, and then we are going to divide it by e to the x. So we will be getting the antiderivative of e to the 3x over ex, e to the x, I mean minus 4 e to the x over e to the x, plus 5 over e to the x dx. Simplifying further, as you remember, for the quotient rule, for example, we have x to the 7 over x to the second is equal to x to the fifth. So we are going to subtract the exponents. And then if we have like this, so 3x, supposing we have that exponent 3x and then minus the exponent in the denominator x. So 3x minus x equals 2x. So simplifying further, we have the integral of e to the 2x plus 4, because we cancelled already e to the x, plus 5 e to the negative x. So we bring e to the x in the numerator, so it will become negative. Continuing, so we have e to the 2x over 2 plus 4x plus e to the negative x over negative 1 plus c. If you want to make e to the negative x positive, you can do it so. We just use e to the negative x so that we can see what is the number that will be divided to 5e when we integrate it. So the final answer is e to the 2x plus 2 plus 4x plus 5e to the negative x plus negative 1 plus c.